आज के दिन का जो टॉपिक है वो है लॉ ऑफ मास एक्शन। लॉ ऑफ मास एक्शन। सबसे पहली बात यह है कि क्वेश्चन आता किस तरह है, इसमें एग्जामिनेशन में किस तरह से क्वेश्चन आता है वो आप देखिए। तो क्वेश्चन नंबर 1 इसका बनता है डिफाइन स्टेट लॉ ऑफ मास एक्शन। स्टेट लॉ ऑफ मास एक्शन and derive Kc and derive an expression for Kc, expression for Kc। दूसरा क्वेश्चन इसका बन सकता है derive Kc for general reaction discuss its units, discuss its unit, and number 3 जो है वो है importance of Kc। अगर देखा जाए तो ये सभी क्वेश्चन जो है अगर ये अकेला आता है तो ये 3 मार्क्स का है, ठीक है। एंड ड्राइव एक्सप्रेशन फॉर Kc ये जो है ये सारा 4 मार्क्स का है, ठीक है। यानी टोटल पूरा क्वेश्चन 7 मार्क का बन रहा है, ठीक है। ये अक्सर लॉन्ग में आता है और ये ज़्यादातर शॉर्ट में आता है, बट कभी कभार ये भी शॉर्ट में आ जाता है, ठीक है। सही, तो 3-3 मार्क्स तो दोनों को कंसिडर कर ले। ड्राइव Kc फॉर जनरल रिएक्शन ये तकरीबन यही क्वेश्चन है, ठीक है। डिस्कस इट्स यूनिट्स एंड इम्पोर्टेंस। अब Kc जो ड्राइव करनी है, मैं कहता हूँ अगर ये 4 नंबर का रख लें, 4 से लेकर 3 नंबर का ये हो गया, 3 या 4 नंबर का ये रख लें। डिस्कस इट्स यूनिट्स ये 2 नंबर का भी होता है और 3 नंबर का भी होता है, ठीक है। और इम्पोर्टेंस ऑफ Kc जो है ये पक्का 3 नंबर का है, 3 से 4 नंबर का क्वेश्चन है, इससे कम का ये नहीं होता। सही, 5 नंबर का भी हो सकता है। तो यानी 4 और 4 8 और 3 कितने हो गए? 11 नंबर का ये क्वेश्चन बनता है। या फिर आप इस तरह कर लें कि 2 और 3 5 और 3 8, या फिर 8 नंबर का ये पूरा क्वेश्चन है। 8 से 11 के दरमियान में ये क्वेश्चन बनता है। ये शॉर्ट में भी आ सकता है, लॉन्ग में भी आ सकता है। लॉन्ग में पूरा आएगा, शॉर्ट में कम आ जाएगा। ये ऐसा भी हो सकता है कि इसका कुछ हिस्सा और कुछ हिस्सा इसका हो, तो उस तरह भी दिया जा सकता है। फॉर एग्जाम्पल आ सकता है स्टेट लॉ ऑफ मास एक्शन एंड ड्राइव डिस्कस इंपॉर्टेंस ऑफ Kc, ठीक है। तो मैं 1 by 1 आई विल डिस्कस ईच टॉपिक। ओके, क्लियर। सो सबसे पहले स्टेट लॉ ऑफ मास एक्शन। बिफोर स्टेटिंग लॉ ऑफ मास एक्शन यू हैव टू राइट सम इंट्रोडक्शन। ओके, सो आवर आंसर इज स्टेटमेंट इंट्रोडक्शन। सॉरी, फर्स्ट हेडिंग क्या होगी? इंट्रोडक्शन। इंट्रोडक्शन क्या होगा? This law was proposed by C.M. Goldberg and Peter Waag in 1864. Okay, so this law tells us about the relationship between the rate of reaction and the concentration of concentration of reactants. So this law quantitatively on the basis of quantity, numbers में, ठीक है। सही है, मैग्नीट्यूड के साथ। So this law quantitatively explains relation between speed of a reaction and concentration of reaction. and concentration of reaction. Concentration of reactants. Concentration of reactants. Is it clear?
Yes, sir.
Clear?
Yes, sir.
Yes, sir.
Okay. So, what is the statement of this law? This law basically states that the mass, the rate at which substances react is directly proportional to the active mass, of the substance. So this is our first statement. In the first statement, this law states that the rate at which a substance reacts is directly proportional to the amount of that substance, concentration of that substance. Okay. So if you increase the concentration, the rate of reacting that species will increase. Okay.
Yes, sir.
If you consider the following reaction, N2 plus 3H2, okay, and gives us 2NH3. If you increase the amount of hydrogen, what will happen? The consumption of hydrogen will be increased. Okay, because if you increase the amount of hydrogen will collide with nitrogen. Okay, the probability of collision between hydrogen and nitrogen will be increased. Okay, so by increasing the concentration of hydrogen, you can increase the reactivity of hydrogen. Clear? You can speed up this reacting rate. Is that clear?
Yes, sir.
But it is not the rate of reaction itself. Reaction rate depends upon the concentration of both. भाई साहब सफी यासर इधर देखना है, ठीक है? So H2 की जो कंसंट्रेशन है और नाइट्रोजन की कंसंट्रेशन है, रिएक्टिंग डिपेंड अपॉन जो आपका जो रिएक्शन है उसकी जो स्पीड है इन दोनों की कंसंट्रेशन पे डिपेंड करती है, नॉट ओनली वन. ठीक है, सही, दोनों की कंसंट्रेशन पे डिपेंड करेगी. So and the rate of reaction, the next statement is and the rate of reaction, ठीक है, reaction itself. ठीक है, एक में substance react करता है, rate of substance है, और एक क्या है, rate of reaction itself है. ठीक है, सही. The rate of reaction is directly proportional to the product of the concentration of reactants or molar masses of reactants. So if you have reactant A and if you have reactant B, okay, so if you increase the reactant concentration of A, you will find that the speed of reacting the species A, speed of the reacting of species A, reagent A will be increased. Okay, if you increase the both, okay, then rate of reaction will be increased. Okay, is that clear?
Yes, sir.
Any confusion? So there are two statements. Okay, one is the statement of reacting species and the other one is rate of reaction itself. And the rate of reaction depends not only on one species, it depends on both. Okay, it is the product of concentration of reactant A and reactant B. Okay, it is directly proportional to concentration of reactant A and concentration B. Okay,
Yes, sir.
is that clear?
Yes, sir.
So here you can write that. Let us consider a general reaction. So this is our next topic is derivation of Kc, derivation of Kc, derivation of Kc. Let us consider general reaction. Our reaction is A plus B gives us C plus D and D. So these are our reactants for the forward reaction, and these are our products for the forward reaction. Since these products are reacting with each other to form these products, these are reactants for the backward reaction.
Yes, sir.
Okay, there are two reactions are taking place at the same time. Is that clear to you?
Yes, sir.
Okay, so if you want to write the rate of forward reaction, so you can define rate of forward reaction is equal to अच्छा RF is directly proportional to KF. RF is directly proportional to the concentration of A to the concentration of B, each has to the power their molar coefficient.
Okay, sir.
Okay, this also determines the rate of reaction. Okay,
Yes, sir.
so what will happen if I increased the amount of A, molar ratio of A, the consumption of A will be increased. Consumption of A will be increased. क्योंकि ज़्यादा चांसेस होंगे ना A के B से टकराने में, तो जितने ज़्यादा इसके मोल्स होंगे उतने ज़्यादा चांसेस होंगे कि ये A कंज्यूम होगा. ठीक है, जितने ज़्यादा A कंज्यूम होगा उतने ज़्यादा आपके पास C और D बनेंगे.
Yes, sir.
बात समझ आ रही है बेटा? खोना नहीं है, ठीक है, यहाँ देखना आपने. सफ़िया सिर्फ त्वचा इधर रखनी है, ठीक है. ओके, सो हेयर वी हैव. अच्छा, इसकी मिसाल ना आप इस तरह ले लें. फॉर एग्जांपल इमेजिन, मैं कभी कभार एक फ़नी एनालॉजी देता हूँ. कुछ लोगों को शौक़ होता है वो क्या कहते हैं उसको, फॉर एग्जांपल आपने मछलियाँ पकड़नी है. क्या पकड़नी है? मछलियाँ पकड़नी है. व्हाट विल हैपन अगर मैं क्या करूँ, उस तालाब के अंदर एक मछली छोड़ दूँ. एक बड़ा तालाब हो इस कमरे जितना, उसके अंदर सिर्फ एक मछली छोड़ दूँ, तो मुश्किल है कि आप उस एक मछली को पकड़ने में अच्छा खासा टाइम लग सकता है. ठीक है, बट इफ़ आई इंक्रीज द अमाउंट ऑफ फिश, नंबर ऑफ फिश इन दैट पॉन्ड, तो क्या होगा अगर मैं वहाँ पे 10,000 के करीब मछलियाँ डाल दूँ, तो आप शायद एक ही बार हाथ उठाएंगे और 10 मछलियाँ आपके हाथ में होंगी. सो इसमें हो क्या रहा है, इसमें आपके अमाउंट नहीं बढ़ रही, इसमें जो मछलियाँ हैं, फिशेज़ हैं, उनकी तादाद बढ़ रही है. ठीक है, तो जितनी ज़्यादा उनकी तादाद बढ़ेगी तो क्या होगा, जितनी ज़्यादा उनकी तादाद बढ़ेगी तो क्या होगा, उतनी जल्दी आप मछली पकड़ पा रहे हैं. ठीक है, कोलिजन के चांसेस बढ़ रहे हैं. सो इफ़ यू हैव ए, इफ़ यू हैव बी, एंड इफ़ यू इंक्रीज बोथ दीज नंबर्स, द रेट विल बी इंक्रीज्ड. इज दैट क्लियर टू यू?
Yes, sir.
So RF equals to KF. This is the proportionality constant that depends upon these two things. Okay, so A, B, B. Okay, similarly here are we have C and D, and you know that C and D are reactants or products? Products, but these are reactants also for the backward reaction.
Yes, sir.
Okay, if you see this backward reaction, then you can say that these C and D are the products for the backward reaction. So you can write that the rate of backward reaction depends upon the concentration of C and D. So RB is directly proportional to, according to law of mass action, the concentration of C and the concentration of D. C over D. Okay, raised to the power their molar coefficient. Each raised to the power their molar coefficient. Okay, so if you remove this proportionality sign, you can write that RB equals to KB into CC into D power D. Okay, this is your equation number 1, and this is equation number 2. Okay, so and you know that at equilibrium, what happens at equilibrium? At equilibrium, what happens at equilibrium?
Rate of forward reaction.
Rate of forward reactions and rate of backward reactions becomes equal to each other. So RF equals to RB. Okay.
Yes.
So if you consider both these rates equal to each other, then you can write, then you can put the value of RF and RB in the equation number 3. Okay. So what is the value of RF? RF is equal to KF into A power A, B power B. The value of RB is equal to KB and C, C, D and D. Here is one thing that you have to memorize. The thing is you should write C and D in numerator. Okay.
Yes.
So how will you do that? By rearranging this equation. If you rearrange this equation, if you divide this equation with KB, okay, also dividing KB here, okay, so you will get that KF divided by KB, which is equal to A into concentration of A, B into the concentration of B equals to KB will cancel each other with each other. Here you have left with C and D. Okay. Now if you just divide this equation number 5 with AA and BB, so you are left with KF divided by KB, which is equal to C and DD in numerator, and in denominator you will left with A power A and B power B. And you know that this value KF by KB, if you divide 4 by 2, what will happen? The answer will be a 2. 2 is constant. If you have value of 4, if you have value of 2, this is 2. 2 is a constant.
Yes, sir.
4 is also a constant. If you both divide these constant, the answer will be only a constant. Is that clear?
Yes.
So KF is also a constant and KB is also constant. So if you divide both these values, so you will left with another constant that is called Kc. So you can write that Kc is equal to this one. This is the final expression of Kc for a general reaction.
Yes.
Is that clear?
Yes, sir.
So if you have if someone asks you that what is Kc itself, that is another question. Okay, that is another question. What is Kc? So you can define Kc. Kc is the
Equilibrium constant.
Kc is the ratio of the
Products.
products of the product. These are the products and their products. Okay, Kc is the ratio of the concentration of the products. Kc is the ratio of the products of the concentration of products. Kc is the ratio of the products of the concentration of products to the products of the concentration of reactants. Okay, you can define Kc from here. Okay, and each raised to the power their coefficient also.
Yes, sir.
I'm going to write here this definition. Okay, you can write this equation. This is also derived in your textbook. Okay, you can see over there and memorize it. This is very important question. Okay,
Yes, sir.
so each one of you has to derive this equation.
Okay, sir.
Clear?
Yes, sir.
So our next question is, what is Kc? This is our question number 6. So I am going to tell you about Kc. Our next topic is Kc, equilibrium constant. What is equilibrium constant? Equilibrium constant. What is equilibrium constant? Equilibrium constant is the ratio of the products, ratio of the products. This product came from multiplication product. Okay, ठीक है. Cross products is the ratio of the cross products of the concentration of the products. Concentration, CONC mean concentration. Concentration of the products to the products of the concentration of the reactants, each raised to the power their molar coefficient. What are these? A, B, C and D are molar coefficient, and each raised to the power their molar coefficient. Each raised to the power their moles. That is enough. Is that clear?
Yes, sir.
Okay, so I have defined here equilibrium constant, and there is little bit chances that this definition is included in your exams. Okay, it is not so important, but the unit of Kc is very important. Very important. So Kc, you know what Kc has? This is a general expression for Kc, and the unit of Kc depends upon its expression. Okay, so you can say that units, it has no specific unit. And its unit depend upon its expression. Its units depend upon its concentration. Depends upon its expression. So if you have to give two examples also. If you give two examples, then everything will be cleared. If you are not going to give examples, then I don't think so this has any worth. Okay, you have to write also. You have to also give examples. Okay, so what are two examples? One is N2 plus 3H2 gives us 2NH3, and other one is other one will be H 2HI plus H2 plus I2. Okay, so here are some examples of units of Kc. For instance, if you have a reaction N2 plus 3H2 gives us 2NH3. What is Kc for this NH3? The concentration of NH3 raised to the power moles. Okay, and H2 and N2 raised to the power their moles. Okay, so this value has mole per dm cube concentration of unit of concentration is mole per dm cube. So put mole per dm cube here also, mole per dm cube here also. This is cube, this is square, and this is 1. If you multiply these value, you will get mole per dm cube whole square, mole per dm cube whole power 4, and this will becomes mole per dm cube sorry, this will becomes 1 by mole per dm cube whole power 2, and the answer will become mole square mole 1 by mole square per dm cube per dm power 6. 2 3s are 6. Okay. Okay. If you take inverse of this expression, you will get dm 6 divided by mole square. Okay. This is your final unit. This is your final unit for this reaction. Okay. So if you have another examples, just take another example. Okay, so from this equation you can say that the unit for Kc is dm6 divided by mole square. Okay, this is the unit of Kc for this reaction. Okay, now I am going to write another reaction H2 plus I2, and this gives us 2 Hi, 2 moles of Hi. So I am going to write here values of this I'm going to write here expression for Kc for this reaction. We have H2 plus I2. Its unit is mole per dm cube divided by mole per dm cube. Here is square, so I'm going to take here square also, and this is mole per dm cube. And if you multiply this mole per dm cube with this mole per dm cube, you will get mole per dm cube whole square, mole per dm cube whole square, and all these value is going to cancel with this value, and you are left with no unit. You are left with no unit. So equation number 1, sorry, this is expression number 1, this is equation number 2. Both these equation number 1 and equation number 2 shows that the Kc has no specific unit. Okay, is that clear?
Yes, sir.
Okay, so here is another question comes in exam regarding this one, regarding the concept of Kc. That is, if you have the reaction, H2O plus H2O react with each other, 2 gives us H3O plus OH. OH negative. Keep quiet. Okay, so there is a question that derive expression for Kc. One is express. The one question is often comes in exam that write expression for Kc. Write expression for Kc. The other question is derive expression for Kc. Derive expression for Kc. So how can you write it? The answer, your answer will be, your solution will be, you know that rate of forward reaction is directly proportional to H2O to the concentration of H2O, and RF is directly proportional to RF equals to KF H2O whole square. Is that clear? Okay, so this is your equation number 1. And if you write rate of backward reaction, what will be the rate of backward reaction? Safiya sir, what will be the rate of backward reaction for this reaction? Yes. H3O RB is directly proportional to H3O plus OH minus sign here. Okay,
Yes, sir.
so if you remove this proportionality constant, you will get RB equals to H3O whole power, sorry, KB equals to H3O plus OH minus. This is equation number 2. At equilibrium, the rate of forward reaction and rate of reverse reaction becomes constant at equilibrium. Okay, so RF equals to RB, therefore you will get that RF, what is the value of RF? Amir Hamza,
Yes, sir.
what is the value of RF? Sorry,
Yeah.
KF, KF
H2O.
H2O whole power 2 equals to, what is the value of RB, Amir Hamza? KB into H3O plus OH minus. Okay, if you just divide these equations with KB, okay, and with H2O whole square, you will get KF divided by KB equals to H3O plus OH concentration of OH negative divided by H2O whole square, and this is your Kc. This is the whole expression for Kc. Okay, if someone asks you to derive expression of Kc for the specific reaction, then you have to derive this one. Okay, if someone give you a typical type of a chemical equation and then ask you to write, then they ask you to derive expression for Kc, then you have to derive in such a way.
Yes.
Okay, if someone asks you to, someone gives you the chemical reaction and then asks you to write expression for Kc, right? Expression for Kc, then you have to write direct expression for Kc. You don't need to write. You don't need to derive all these things. Okay.
Yes, sir.
Okay. So there are two questions. One is derive and the other one is
Right.
write. So there are main difference between, and in derivation you will do all this stuff. Okay. And in writing you will only do write the reaction and then write this stuff here. Is that clear?
Yes, sir.
So okay, and the other question is that derive a Kc expression for general reaction. So general reaction, what is general reaction? A plus BB. Is that clear?
Yes, sir.
That we have did earlier. Okay,
Yes, sir.
is that clear?
Yes, sir.
Okay, so any question,
No, sir.
any problem? So what is the importance of Kc? Another question is importance of Kc. What is the importance of Kc? Kc, that is given in your book, page number, if you open your book and read page number 14, number 1, Kc can be used to determine the equilibrium concentration of equilibrium mixture knowing the initial concentration of reactants. If you know the initial concentration of reactants, then you can predict out the concentration of reactants and products at equilibrium. Okay, you can say that on which concentration the equilibrium is going to be established. You can predict the concentration of reactants or product on which equilibrium is going to be established. Is that clear?
Yes, sir.
ओके आप बता सकते हो कि वो कौन सी कंसंट्रेशन है जिस पे हमारे पास इक्विलिब्रियम एस्टेब्लिश होगा. सिर्फ आपको शुरू में पता है, आपको शुरू की वैल्यूज़ पता है, तो आप बता सकते हो कि भाई किस जगह पे जाके ये इक्विलिब्रियम में आ जाएंगी, किस कंसंट्रेशन, जब इक्विलिब्रियम आएगा तो आपके पास रिएक्टेंट्स की क्या कंसंट्रेशन होगी और प्रोडक्ट्स की क्या कंसंट्रेशन होगी. ओके, इक्विलिब्रियम के टाइम पे जो कंसंट्रेशन होगी उसके बारे में आप बता सकते हैं. पहली बात ये है. नंबर 2, प्रेडिक्ट द केमिकल डायरेक्शन ऑफ अ केमिकल रिएक्शन. आप डायरेक्शन बता सकते हैं. क्या बता सकते हैं? डायरेक्शन. अगर किसी की कंसंट्रेशन से ज़्यादा वो रेशो आ रही है, फिर खैर ये फर्स्ट ईयर में, बाकी हम इसको पढ़ेंगे, तो आप डायरेक्शन प्रेडिक्ट कर सकते हैं. अभी इतना काफ़ी है आज के लिए. ठीक है, डायरेक्शन प्रेडिक्ट कर सकते हैं। एंड द एक्सटेंट ऑफ केमिकल रिएक्शन, आप एक्सटेंट बता सकते हैं। इफ वैल्यू ऑफ केसी इज़ वेरी ग्रेटर, आप कह सकते हैं जो रिएक्शन है वो ख़त्म होने वाला है। केसी की वैल्यू बहुत स्मॉल है तो आप कहेंगे रिएक्शन अभी स्टार्ट हुआ है, ठीक है। तो ये खैर इतनी लंबी बातें, लंबी चौड़ी बातें वो करने की ज़रूरत नहीं है। यू जस्ट हैव टू राइट दैट प्रेडिक्ट द एक्सटेंट ऑफ केमिकल रिएक्शन। ओके, द अदर वन इज प्रेडिक्ट द इफेक्ट ऑफ चेंज इन द कंडीशन ऑफ द केमिकल रिएक्शन ऑन द इक्विलिब्रियम स्टेट। तो ये आपके बीएससी में जब हम पढ़ते हैं तो बीएससी में 4th ईयर में जब हम जाते हैं वहाँ पे हम इसको देखते हैं। बट आप ये याद कर लें कि भाई अगर केमिकल इक्विलिब्रियम के अंदर, केमिकल रिएक्शन के अंदर जब इक्विलिब्रियम स्टेट में हो तो उसमें कोई भी अगर हम चेंज करेंगे, ठीक है, कोई भी कंसंट्रेशन में, प्रेशर में या वॉल्यूम में चेंज करेंगे तो उससे इक्विलिब्रियम पे क्या चेंज आएगा, ये सारा हम उसमें स्टडी करते हैं। इज दैट क्लियर?
Yes, sir.
ओके, आई थिंक इट्स इनफ। द अदर वन इज ली शार्टर प्रिंसिपल, ये हम कल के लिए रख लेते हैं, ठीक है। ओके, अल्लाह हाफिज़।